Hi guys, my name's Kyle, and I wanted to talk to you guys about a side project I've been working on that allows you to run your updater as soon as RS updates, specifically old school RuneScape. So the code I have in front of us is written in JavaScript, and it's a node worker process that basically its only job is to connect to RuneScape using their update protocol, and this uh, intel was provided by Pyro Ryan. He provided a Python script which uses a very similar syntax right here and library, but this is written in JavaScript. So props to him for providing that, and then I believe he released that with like revision 2 of Old School RuneScape back in 2013. So granted, that's not necessarily new tech, but it was good to be able to find that on RS Hacking. So what are we looking at, right? This is just some code that allows my program to check to see if Old School RuneScape is up to date. If you give it a revision to check, and you can see that right up here. So we open up a socket using the Old School RuneScape host and port. So the host is configurable. It's just a host name, oldschool 1.runescape.com, and the port will pretty much always stay the same, and that's 43594. But if you want to test it against a private server or something, you can do that. By the way, this is open source. You can go check it out. runetech/update-monitor. It's on GitHub. That said, it's not very complex code, and you can reproduce it in like 2 or 3 minutes. So so this is just a method that allows you to check if a revision is up to date. It sends some packed data to the update server, and RuneScape basically just replies with an opcode. In this case, it's 6 if your client's outdated. So what we do is using the JavaScript's ES6 promises API. This just allows you to chain multiple methods without using callbacks. So this is more or less a return statement, and we just say, okay, well, the backup you got back does not equal outdated. So if it is not 6, then we basically just return true here. Otherwise, we're returning false. Which allows us to create, I'm not going to go through all this, but this allows us to create a couple cool utilities like a recursive version finder. And all this does is it checks the revision, which we saw in that last file. And if we see that it is up to date, then we update the revision, right? And then we also spawn this process called background updater. And all that does is basically, since we know the revision is correct, that's like a code contract here, so we know that we have the right version, then all we do is every 5 seconds by default, we increment, or we check to see if the current revision plus 1 is up to date. If it is, then we set it up to date, and we broadcast a message as well that like an update has taken place. And so then using Redis's pub sub, and Redis is a key value store. It also has some pub sub functionality built into it though. So you can use this across languages as long as your Redis library supports it, which is really cool and allows you to build cross-app communication using a common interface. So as long as you know the message that this process is going to send out, you can listen for it and know what to do when you see that. Okay, that's cool. Now we know like that RS is updated. What can we do with that? Well, I built a little project here, a web interface where you can go and upload your updater jar. And now I don't expect people to do this, and honestly, I don't really expect to ever make this website live. I'm just showing you guys some cool stuff you could do. But if we just drag and drop a file on here, like here's an old updater, drop it, upload it successfully. It says click the ship icon, and this allows us to start a Docker container. And Docker, if you haven't heard about it, you can go to docker.io. It's a website, and it allows you to run Linux containers, which are very lightweight and have a lot, or not too much isolation, but they're quite fast, or a lot faster in comparison to virtual machines, as there's no virtualization layer, and they share CPU cycles with their host. So, with that said, all this page does is, since you've uploaded a jar, and we're on that jar's containers page, what we can do is we can just spawn a new container, and it pulls down a special Docker image, which basically all it has in it is very lightweight Linux distribution with just Java installed, and that's pretty much it. So if we go ahead and click start, we'll see that it's running, and it usually takes about 15 seconds, and that's because I'm running, or it's going through Docker, which for me is hosted inside of a virtual machine because my operating system doesn't support it. Okay, it completed. But if I were to run this on my host machine through IntelliJ, it would take like 4 seconds. So 14 seconds, not too bad. Pretty quick feedback. We can go ahead and view the log, and the updater, or I modified the updater to use a little micro library that basically the only functionality it exposes is the ability to identify hooks when you come across them. So you can add method hooks, callbacks, fields, identified classes, etc. And then the Docker container, or at the, once your updater has ran, and I'll get to the life cycle of that in a second, the library that I wrote just dumps this to a file on disk and then exits. So we can see the callbacks, fields, all that. And so if we look right here, we can see this ID. You can also see it in the URL up here. This is what's called a trace ID, or I call it a trace ID, and it's basically the web server that runs this website is not the same that spawns the Docker containers, nor is it the same that checks for the RuneScape updates. And so this allows this server to be able to track the execution of the container throughout its lifecycle. So when it starts a container, it sends it off to another service, and it's just a small, like 100 or so line Node.js application, which basically just spawns a Docker container with your jar. And it's pretty smart when it does this. It mounts 3 virtual file systems. 2 of them are read-only, and those are the first being, it's just a directory with all of the OldSchool RuneScape client revisions inside of it. And so it's read-only, you can't write to it, but it allows your application to not be responsible for going out and downloading or finding that client revision. This second read-only file system is just a single, it's a basically just a folder or directory path with the only file contained at the leaf node being your updater jar. And so basically what gets run is something that looks like this: java-jar, and then it's like this, and then whatever the hash of your jar is. So let's say cafe babe, because you know, Java magic numbers. And then we pass it 2 things. So we pass that trace ID that we get, and oh boy, so we pass that trace ID, you know, the UUID that you saw in the URL, as well as we pass the path to the jar that you're supposed to be, or the client revision jar that you're supposed to be running against. And in turn, that allows the library that I built to take in that trace ID, and then once it's done, it writes your JSON log file, what you see right here, to another mounted volume that just has that trace ID followed by, or that trace ID with a .json extension. And once that's done, it basically just tells this web server, which again, different application, different process, that it's done executing. And so yeah, that's pretty much it. If you guys have any suggestions other than being able to specify the client revision, then I'd be glad to hear it. So thanks for watching, and hope you enjoyed.